Hello, hello, Ishwant. Hi, hi, good evening. Hello, my dear friends. Still anyone is in live? Still anyone is in live? Hi, Subhana. Hi, hi. Hi, Kalavati. Good evening, good evening. Jasmine, good evening. May I know who is this Kalavati? May I know who is this Kalavati? May I know? Good evening. Good evening, Sai Vaishnavi. Good evening, Akshara. Now, Vipul, the class timing is 9:30. 9:30, 9:30. Right. Now, my dear friends, may I know, uh, last class we have done up to the hybridization, right? Now, actually, due to the some current issue, Kirtana. Okay, okay. Okay, Kirtana. Right, right, right. Due to some current issue, uh, what I was doing, I was just minimizing my, or I was turning off my camera. Just you can focus on the just class itself. Now, before going to start the lecture, I just want the information that is the voice is clear, voice and the video is clear. If the voice and the video, if it is clear, now I will start the lecture. Is the voice and the voice is clear? Is the voice is clear? No. Yes, yes. Now the yesterday we have seen the what? Yes, yes. Okay, fine. Now yesterday we have seen what? Hybridization of the molecules we have seen, and we have seen the trick. Now we are going to today we are going to see the hybridization of the organic molecule. No. Hybridization for organic molecules or organic compounds. If the organic compound they have given, how to identify the hybridization for it? Organic compounds. Hybridization for the organic compounds. Now in this hybridization to identify in the organic compounds, here let's suppose one compound they have given CH2 double bond C double bond CH bond. Now CH3 if they have given. Now here what you have to do, the main point, key point you have to remember here is, the key point you have to remember, each hydrogen, each hydrogen consider as one sigma bond. Each hydrogen considered as one sigma bond. Right? Now, here to identify the hybridizations of the each carbon in the organic compounds, for that one we are having a one formula. What is that formula? Now, the to identify the hybridization in the organic compounds, hybridization is equal to number of sigma bonds plus number of lone pairs. Number of lone pairs. Now you can see here the number of sigma bonds plus number of lone pairs, and that too if the hybridization number after the calculating number of sigma bonds plus the number of lone pair, if the hybridization number 2, if you got that hybridization is sp, if we got the 3, that is sp2, if you got the 4, that is sp3. Now carbon will never and ever will show the sp3d, sp3d2 hybridization. Why? Due to absence of d orbital. Due to the absence of d orbital, it will never and ever show the which one? It will never and ever will show the sp3d and the sp3d2 hybridization. I hope it is clear. Now, here based on this one, based on this formula, now we are going to find the hybridization of this given compound. Clear? No. What is the hybridization of this given compound? Now we are going to see how to identify the hybridization. Here, now you can see here how many hydrogens we are having? 2 hydrogens, right? And 1 sigma bond. 2 hydrogens and the sigma bond. Hybridization is equal to number of sigma bonds. How many? 2 hydrogens and sigma, right? 3 plus 0, because lone pairs on the carbons are 0. So the hybridization number 3, if we got, that is sp2. When this carbon hybridization is sp2. Now the central carbon hybridization, here the 1 sigma, here the 1 sigma. We should not consider the pi, okay? Only sigma bonds you have to consider. This is sp. Now here the 1 sigma, 1 hydrogen and 1 sigma. Hybridization number 3, it is sp2. Now here we are having the 3 hydrogens, 3 sigma bond, and here 1 sigma bond. Total hybridization number 3, that is sp3. Clear? Now in this manner you have to find. Now I will give you one question. Hello, Rudra. Hello, Rudra. Now here the CH3, CH double bond, C triple bond, and CH and the CH3 they have given. Now you say me what is the hybridization of the first carbon? What is the hybridization of the second carbon? What is the hybridization of the third carbon? What is the hybridization of the fourth carbon? And what is the hybridization of the fifth carbon? May I know what are the hybridizations of the first carbon, second carbon, and the third carbon and the fourth carbon? Can anyone say me what are the hybridizations of the first carbon? Now, my dear commander, what is the doubt you are having? Now, the first carbon is a sp3. Yes. The first carbon is a sp3. Yes. My dear friend, yesterday itself I did the very beautiful lecture and I was said the very interesting trick and everything. I explained very clearly. My dear friend, you can go and watch that lecture. What is the hybridization? You will get to know. Intermixing of atomic orbital leads to give the hybridization. Clear? Now first one is sp3. Second one, good. Akshara sp2. And third one, third carbon hybridization. Third is sp. Good, everyone, good. Third is sp. Third carbon is sp. Now fourth carbon, my dear friends, fourth carbon. Good. Third carbon is sp. And the fourth carbon is sp2. Good. Fourth carbon is sp2. Fifth carbon is no. Fifth carbon is not sp2. Good. Fifth carbon is sp3. Right. Now here, depending upon the hybridization, yes, fifth carbon is sp3. Now next question if they have given CH3, CH2 and OH if they have given. Now what is the hybridization of oxygen here? What is the hybridization of oxygen here? What is the hybridization of oxygen here? Good, 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 my dear friend. Commander, good. Rudra, good. Joshita and Akshara, Jasmine, Tanish, Subhana. What is the hybridization of oxygen here? What is the oxygen hybridization? What is the oxygen hybridization? No. Yes, oxygen hybridization is sp3. Oxygen hybridization is sp3. Why? Because here oxygen, it contain lone pair, right? Now two sigma bonds and the two lone pairs. Clear, hybridization is equal to now two sigma bonds and two lone pair. Hybridization number 4 we got, right? So the hybridization is sp3. Clear? Now the oxygen hybridization is sp3. May I know what is the hybridization of this carbon? Carbon number 1, and this is the carbon number 2. What is the hybridization of carbon number 1 and what is the hybridization of carbon number 2? What is the hybridization of carbon number 1 and what is the hybridization of carbon number 2? What is the hybridization of carbon number 1 and what is the hybridization of carbon number 2? No. What is the hybridization of carbon number 1 and the carbon number 2? What is the hybridization of carbon number 1 and the carbon number 2? Both the carbons hybridization is sp3 and sp3, because here the two hydrogen sigma and one sigma and the one sigma. Total hybridization numbers are, hybridization number is 4. So both the carbons, yes, yes, yes. Both the carbons hybridization is sp3. Right. Next one, the next topic that we are going to study, that is a percentage S character. This is a very, very important. Now with the help of this one, we can use this application in the many of the topics. Right. Now how to calculate the percentage S character? For that one, now the SP if you take, and SP2 if you take, and the SP3 if you take. Now in the SP, how many s orbital we are having? Only the percentage s character. The s orbital we are having only one, and the total number of orbitals we are having 2. Clear? The 1 by 2 into 100 will give you the 50 percentage s character in the SP. Done. And the second one, we are having the 1 s orbital. Clear? And total 3 orbitals, right? Now so 1 by 3 into 100 will be given for the sp2. That if you calculate, you will get it as a 33.3 percentage. Now in the sp3, 1 s we are having, and 4 orbitals we are having, 3 and 1 s, total 4 into 100. That it will give you the 25 percentage, right? Clear? Now the percentage s character. Now this is the one key point you have to remember. What is the key point you have to remember? As the percentage s character increases, orbital will be closer to the nucleus, closer to the nucleus. Clear? And its electronegativity increases. So you have to be very careful with this one. Means as the percentage s character increases, electronegativity increases. Now can you say me, now among the sp2 and the sp3, which is having the higher electronegativity? Which is having the higher electronegativity? Is the voice is getting echo? My dear friends, is the voice is getting echo? Is the voice is clear or it is getting echo? Is the voice and everything is clear? Then after that, SP is having the higher electronegativity because it is having the 50% S character. Next it is having the 33.3% S character. Next one it is having the 25% S character. Now, yes, okay. My dear friends, if you are having any disturbance, you can say me whether the regarding the voice or video and everything. Okay. Now this is the electronegativity order. SP greater than SP2 greater than SP3. SP greater than SP2 greater than SP3. Right. Now here this is a percentage S character we can calculate. The next one we are going to see. The next very interesting topic that we are going to see. It is getting echo now. Now is the voice is clear now? Now is the voice is clear? Is the voice is clear now? Still it is getting echo. Hello. Still you are getting echo or is the voice is clear? Okay, fine. Now the voice is clear, right? Okay, done. Okay, fine. Now the voice is clear, right? Okay, done. Now the next very important topic that we are going to study, that is the next very important topic that we are going to study, it is MOT. My dear friends, the MOT concept is very important that we are going to study. Now, the next topic we are going to study, that is molecular orbital theory. Molecular orbital theory. First, we will finish this molecular orbital theory. Now, whatever may be the leftover topics that we will see after this one, because this topic is very important, clear, and the plenty of the question they may ask from the MOT. So, first we will clear the MOT. Then after that, whatever the leftover topics we are having, that we will cover. Now, first, why we are going to study this molecular orbital theory? Because now by the Lewis structure, we can't explain the molecule is diamagnetic or paramagnetic. Whether it is a diamagnetic or paramagnetic, we can't explain. Clear? Now that whether the given molecule is a diamagnetic or the paramagnetic, it was explained very clearly by the concept called the MOT. Clear? Now what is the MOT and what we are going to see and what we are going to study in this MOT? Because now what we are going to study in this MOT? Now actually this MOT is nothing but extension of the valency bond theory. Now what is the extension of the valency bond theory and what we are going to study? Here, first of all, by using the physics concept, what is the physics concept that we are going to use here? That is a one interference. By using the physics concept interference, with the help of this one, we are going to study about the MOT. Now what is the meaning of the interference means? Interference is nothing but combining of two waves. Combining of two waves. If the two waves are combining, that we call it as a combining of the two waves, we call it as a interference. Here we are having the two types of the interference. One is constructive interference. One is a constructive interference, and the second one is a destructive interference. One is a constructive interference and the another one is a destructive interference. Hello Astrid, hello, good evening, good evening. Clear? Now what are the constructive interference and what are the destructive interference? Now how it will be useful in the which one? In the molecular orbital theory. In the molecular orbital theory, what is the constructive interference and what is the destructive interference will play very crucial role. Now before going to start the constructive interference and the destructive interference, here by using the orbital or by using, my dear friend, today timing live for the advanced class is 9:30. Now by using overlapping concept, by using the overlapping concept with the help of the interference, we are going to study the molecular orbital theory. Clear? By using the overlapping concept with the help of interference. Now what is the overlapping? Now overlapping already we have studied very clearly, right? Now one atomic orbital plus one atomic orbital intermix leads to give the bond we know. Here in the MOT, one atomic orbital and another atomic orbital, that it will be overlap leads to give the one anti-bonding molecular orbital. Clear? And one is a bonding molecular orbital. One anti-bonding molecular orbital, one anti-bonding molecular orbital it will give. Now what is the anti-bonding and the bonding means? Just example I will say. If you take the one s orbital and one s orbital, this is a one s orbital, this is a one s orbital. One s orbital overlaps leads to give the which bond? Can anyone say me? One s orbital overlaps leads to give which bond? One s orbital overlaps leads to give which bond? Can anyone say me? One s orbital overlaps leads to give which bond? One s orbital overlaps leads to give which bond? Say me, my dear friends, one s orbital overlaps leads to give which bond? One s orbital overlaps leads to give the sigma bond, right? Clear? Sigma bond. Now here the sigma, that you will get the sigma star ABMO. Now and the sigma 1s BMO. Sir, what is this sigma ABMO and the sigma BMO? Now to understand the sigma BMO and sigma ABMO, now here to get the sigma BMO and sigma ABMO, that to understand very clearly, here we are going to use the concept called the interference concept. Here we have the concept called the interference concept. Now first one, the interference concept. Here the orbitals will overlaps in the form of waves. In the form of the wave, the orbital will be overlap. Clear? Now the first one, we are going to see the constructive interference. Constructive interference we are going to see. Now, what is the meaning of the constructive interference? Means if the two waves, this is a wave. Clear? Now this is a one orbital wave. Let assume this is a psi A. This is a one positive phase and this is a one negative phase. When the two waves are combining with the same phase, now this is the one psi B. This is the one psi A and this is the one psi B. When they are combining with the same phase, the resultant wave amplitude will be increases. What? The resultant wave amplitude will be increases. Clear? Means the resultant wave amplitude increases means probability of the finding the electron also increases. Probability of the finding electron also increases. Clear? This is a psi A and this is a psi B. Now this one will give you the psi A plus psi B. But here it is showing, we know that probability of the finding the electron may be equal to the 0, but it should not be the negative. You can see the electron is showing the negative phase. When the electron is showing the negative phase means that indicating that probability we are getting the negative, but actually the probability it should not be the negative. So then what we have to do? We have to take the probability density square, right? Then we have to square the orbital. Now this is a psi square. Now when the waves are overlapping with the same phase, now the probability may be positive, but it should not be the negative. Clear? Sir, probability may be 0, but it should not be the negative. Right? Now, what we have to do? Now, for everyone, is the voice is not clear? Is the voice is clear now? My dear friends, is the voice is clear? My dear friends, is the voice is clear now? Everyone, is the voice is clear? Voice and the video, is it clear? For everyone, is the voice and the video is clear? Right. Yeah. Now, next, the probability may be right. Now the probability may be equal to 0, but it should not be the negative. So what we have to do? We have to make it as a psi square probability density square. Clear? Or we have to make it a probability density square. Now when we make the probability density square, now this one will be the psi A plus psi B whole square. Now we know it is in the form of A plus B whole square. Now psi A square plus psi B square plus 2 into psi A plus psi B. Now we can see, now we got the probability in the positive. Now we got the probability in the positive. Here it is showing that the probability of the finding the electron is maximum, and this leads to give the clear. Now the constructive interference. Now this orbital overlap in the form of the waves. Now the constructive interference when they are overlapping in the same phase, it leads to give what? Bonding molecular orbital. It leads to give the bonding molecular orbital. If the orbitals are overlapping with the same phase, we are getting the BMO. Next one. Second one. Destructive interference. Next one we are having the destructive interference. The next one we are going to see the destructive interference. What is the meaning of the destructive interference? If the orbitals are overlapping with the different phase, the orbitals are overlapping with the different phase. The orbitals are overlapping with the different phase. Then what we are getting? Now the resultant wave amplitude is getting cancelled out. The resultant wave amplitude is getting cancelled out is called as a, the resultant wave amplitude is cancelling out is known as a destructive interference. Right? Now this is a psi A plus psi B. Voice is not clear. My dear friends, it is happening for everyone or only for the few? This voice is not clear. I was getting the some text. Ishwant is saying the voice is not clear. It is for everyone or? My dear friends, is this issue is for everyone or only for the few? Right. Maybe your network issue, my dear friend, once you cross check. Now here this one will give you they are cancelling out. Now this is a psi A minus psi B. They are overlapping with the which one? Negative phase. When they are overlapping with the negative phase, then the probability it should not be the negative. Then if you do the whole square, psi A square and the psi B square, then what you will get? Psi A minus psi B whole square. Now it is in the form of the a minus b whole square form of psi a square plus psi b square minus 2 into psi a psi b. Right, now we got the probability in the negative. We got the probability in the negative. Now it is clear. Still disturbance and everything it is getting. Right. Now here this is indicating that the probability of the finding, here we are getting the probability negative, means the destructive interference it leads to give ABMO molecular orbital. Clear? Destructive interference, when the orbitals are overlapping with the negative phase, we are getting the ABMO. If the orbitals are overlapping with the same phase, we are getting the BMO. Now we are going to see BMO orbitals formation. How the BMO orbitals are formation, we are going to see. Now here two atomic orbital overlaps leads to give two molecular orbitals. Either it may be the ABMO, either BMO. Now the BMO, any orbital, when the orbitals are overlapping, leads to give the molecular orbital. Bonding molecular orbital means they have to overlap with the same phase or different phase. Now my dear friends, say me, to get the bonding molecular orbitals, those orbitals should be overlap with the same phase or the different phase. Now I was taking the 1s orbitals I was taking. When I was taking the 1s orbitals, I Aditya. Now this 2 leads to give the sigma 1s bonding molecular orbital, means this 1s orbital and this 1s orbital should be overlap with the same phase or different phase. It should be overlap with the same phase, right? No. Here the 1s orbital and this 1s orbital. Good, Jasmine. Good. This 1s orbital and this 1s orbital should be overlap with the same phase. It should be overlap with the same phase. When they are overlapping with the same phase, we are getting the sigma 1s bonding molecular orbital. Right? Next one. If you take the 2s orbital also, yes. If you take the 2s orbital also, 2s orbital and the 2s orbital, when they are overlapping with the same phase, now it leads to give the sigma 2s bonding molecular orbital. Now when it comes to the p subshell, we are having the 3 orbital, right? One is px, one is py, one is the pz. Right? Internuclear axis, if I was considered it as a pz, now the pz orbital and one 2pz orbital and one 2pz orbital, and another 2pz orbital. If they are overlapping with the same phase, it leads to give the sigma bonding molecular orbital of 2pz. Right? Sigma bonding molecular orbital of 2pz. Next one, for the pz, remaining px and the py are perpendicular, we know. For the px, for the px and the py are perpendicular. This is py and this is the px, py and the px, 2py and the 2px. When they are overlapping with the same phase, the sideways overlaps leads to give the pi 2px, pi 2py, BMO. Here, now in this manner, now we got the molecular orbitals. Now we'll see the ABMO formation, anti-bonding molecular orbital formation. Now the ABMO is forming with the different phase, right? Now if the 1s orbital, when they are overlapping with the different phase or when they are overlapping with the opposite phase, it leads to give the sigma star 1s antibonding molecular orbital. Antibonding molecular orbital. Next, this is a 2s and this is a 2s. 2s when they are overlapping, it leads to give the sigma star 2s antibonding molecular orbital. Sigma star 2s antibonding molecular orbital. I is the voice is not getting? My dear friends, voice is not getting? Is the voice is not clear? My dear friends, is the voice is not clear? Now the next we are having. Now if the one orbital is overlapping with the opposite phase, now where it leads to give the sigma star 2pz antibonding molecular orbital. My dear friends, is the voice is clear or not? Can anyone? Can anyone say me is the voice is clear? Now, okay. Hello, clear only, right. Now, it leads to give the sigma star antibonding molecule sigma 2pz antibonding molecular orbital. Now, we are having the one 2px and 2py, 2px and 2py. My dear Anjali, once you can uh, what restart your YouTube once so that it may be clear for you. 2px and the 2py antibonding molecular orbital. Antibonding molecular orbital. Right now, here we have finded the this many molecular orbitals. Now, in these molecular orbitals, now we have to find the energy order. Now, the energy of the which one? This molecular orbital. In these molecular orbitals, we have to fill the electrons. First, what we have to do? We have to fill the electrons. To fill the electrons, we have to know the which orbital is having the lower energy. In which orbital we have to fill the electrons. We have to follow the energy order. Energy order. Now this is experimentally given, this energy order. Now we have to remember this energy order up to 14 electrons. Which one? Up to 14 electrons. Up to the 14 electron, the energy order will be what? Sigma 1s greater than sigma star 1s greater than sigma 2s greater than sigma star 2s. Next, here the pi 2py equal to pi 2px. Clear? Next, sigma 2pz. Next, pi star 2px or 2py equal to pi star 2px. And the next one is a sigma 2pz. Sigma 2pz. Now this is the energy order we have to follow up to the 14 electron. Next, the next energy order we have to follow up to or above 14 electrons. Above 14 electrons, we are having the same energy order we are having, but the only the difference, the same energy order we are having, but the only the energy difference we are having. The same, the only the energy difference we are having. right? The only the energy difference or the energy order difference we will have here. The first sigma 2pz, next pi 2py equal to pi 2px. Clear? Pi 2py equal to pi 2px. Next, may I know why this only the energy order difference it has came up to the 14 electrons and the above 14 electrons? Why only this energy difference it has came? Why only this energy difference it has came? Can anyone say me? Above 14 electrons and the up to 14 electrons. Why only this energy difference it has came? Why only this energy difference it has came here? Can anyone? Can anyone say me why only this energy difference it has came here? Can anyone say me why the energy difference up to the 14 electrons and the above 14 electron, why this it has came? If you know the answer, say me the S. If not, give me the question mark. I will explain. Now we know, right? Correct. Up to 14 electrons, up to 14 electrons, and above 14 electrons. Now the 2s and the 2p intermixing, 2s and the 2p intermixing will not be happen. So the 2s and the 2p intermixing will not be happen. This is the lithium, beryllium, boron, carbon, and the nitrogen. If you take 2s and the 2p intermixing will not be happen. Sp mixing is not allowed. Here up to 14 electron sp mixing is not allowed. Up to the nitrogen sp mixing is not allowed. Now after the oxygen and fluorine sp mixing is allowed. Here the sp mixing is allowed. Now why? As the electronegativity increases, now as the electronegativity increases, 2p orbitals energy is decreasing. 2p orbitals energy is decreasing. Now as the 2p orbitals energy is decreasing, what it will happen? Now the sp mixing is allowed. Now here the sp mixing is not allowed. sp mixing is not allowed. Now as the sp mixing is not allowed, now what it will happen? The energy. What? That's the reason we got the difference here. The sigma 2pz and the pi 2py and the pi 2px, the difference it has came because here up to 14 electrons sp mixing is not allowed. That's the reason pi 2pz is having the higher energy. Now here the sp mixing is allowed above the 14 electron. That's the reason the sigma 2pz is having the lesser energy. Clear? Done? No. Now after that we have to fill the electrons. Now to fill the electrons, the same. Now we have studied in the which one? When we have studied the which one? Atomic structure. There I was explained very clearly, right? To whenever we are filling the electrons. Why it is getting echo? Now also it is getting echo. Hello? 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 Is my voice is clear now? Is the voice is clear? Now is my voice is clear? Or still you are having any confusion, or sorry, still you are getting any echo or any disturbance in the voice? Any disturbance you are getting in the voice, or is it clear? Clear. Right. Now, now, now we have to fill the electrons. Now we have seen the atomic orbitals, right? Now, in these atomic orbitals, now we have to fill the electrons. First, MOT diagram of N2. MOT diagram of N2. Now, how the MOT diagram of the N2? First, the 1s orbital and the 1s orbital. 1s orbital and the 1s orbital. This is the 1s orbital and the 1s orbital. 1s orbital overlaps leads to give the sigma 1s, and one is a sigma star 1s. Right? The next one we are having the sigma 2s. The next one we are having the sigma 2s. Clear? Now this is a 2s and this is a 2s. It leads to give the sigma 2s, and this leads to give the sigma star 2s. Right? Next one we are having the p orbital. P orbital we are having the 3 orbitals. Right? This leads to give the pi 2p y, pi 2px. Clear? And next one we are having the which one? Sigma 2pz. Next one we are having here pi star 2px, and the next one we are having the pi star 2py. This is a pi star 2py. This is a pi star 2px. No, my dear friends. Coordination chemistry and that VBT and this VBT, it is, I mean, like, concept is same only, but molecules are different. That's it. Concept is same only. That VBT concept, whatever we have studied over there, and here what we are studying, it is same only, but only the difference is the molecule. There we are going to see, the one coordination complex, right? Like this coordination complex PTCl 4 minus 2, like that. Now the coordination complex there we will see, but here just normal molecules we are going to see. Now here, right. Now here up to 14 electrons, we have to fill the electrons. This is 2pz, px and the py. This is pz, px and the py. Now the 14 electrons we have to fill in the nitrogen. Now 1s orbital we are having the 2 electrons. This 2s orbital we are having the 2 electrons. Here the 3. Each orbital we are having the 7 electrons. Right? Now the 14 electrons we have to fill in these atomic orbitals. Now each orbital will be occupy the 1 electron, right? So 2 electrons, right? Now 1s2 and sigma star 1s2 and sigma 2s and the sigma star 2s and the pi 2py, it will accept the 2 electrons and the sigma 2pz. Now see, all the 14 electrons are filled in the atomic orbitals. Molecular orbitals. All the 14 electrons are filled in the molecular orbitals. Now you can see, are you seeing any electrons unpaired in the molecular orbitals? No, right? That's the reason. N2 is a diamagnetic in nature. N2 is diamagnetic in nature. Clear? Now the only difference, this is a molecular orbital diagram of the which one? N2. Now we are going to see the molecular orbital diagram of the O2. The O2, only the difference we will get here. What is the difference in the O2 we will get? Now the O2, the difference we will get, first sigma 2pz we will get. Then after that, here we will get the sigma, now here we will get the sigma 2py and here the sigma 2px. Right? Now the oxygen we are having the 18 electrons, right? So total 16 electrons we have to fill. Now up to here we have filled the 8 electrons. Here the 9, here the 10, here the 11, here the 12, 13, 14, and here it is a 15, and here it is a 16. Now we can see here in this pi star 2py and the pi star 2px we are having the unpaired electron. That's the reason O2 is a paramagnetic in nature. Paramagnetic in nature. Clear? Now this was explained by the which one? MOT. Now by this application of this MOT, by using this application of this MOT, we have to solve the n number of questions. What are the n number of the questions that we are using the applications of the MOT? By the application of MOT, first we are going to see stability. Stability. Second one, we are going to see the bond order. Third one, we are going to see the bond strength. Fourth one, we are going to see the magnetic nature. Fifth one, we are going to see the bond length. Clear? Now, how to identify the stability means if non-bonding electrons, bonding electrons are high than the non-bonding or anti-bonding electrons, if the bonding electrons are higher than the anti-bonding electrons, that is stable. Now how to identify the bond order means, less electrons in ABMO, more bond order. Clear? Now next one, higher the bond order, higher is bond strength. Clear? Now odd electrons are para. Odd electrons are having para, but even number electrons only 10 and 16 electrons. If it is having 10 and 16 electrons are having, those are para. Remaining all are dia. You have to be very careful with this one. For the magnetic nature, even number of electrons, if the 10 electrons and the 16 electrons if they have given, those are para, remaining all are dia. Bond length, if they are asking, bond order is inversely proportional to the bond length. Now one by one, now we'll see. First one, stability, if they ask. Now first one, Li2, if they have given, Li2 contains 6 electrons, right? Now whether it is a stable or unstable, now we'll see. We know sigma 1s, sigma star 1s and sigma 2s, right? Now the sigma 1s we are having the 2 electrons, sigma star 1s we are having the 2 electrons, next sigma 2s we are having the 2 electrons, right? Now the sigma 1s bonding molecular electrons, number of bonding electrons are 4, number of anti-bonding ABM electrons are 2. Clear? Now if the NB electrons are greater than NAB, now stable, right? It is stable, right? Now next one, if suppose helium or helium-2 they have given, He2 they have given, He2 contain 4 electrons. Now 4 electron means sigma 1s and the sigma star 1s. So the sigma 1s we are having the 2 electrons, sigma star 1s we are having the 2 electrons. Now you can see NB electrons are 2, Na electrons are also 2. Now NB equal to Na, unstable. This does not exist only. Right? Clear? In this manner we have to identify. Now my dear friends, now I will give you one molecule. You have to say me how many electrons are in the bonding, how many electrons are in the antibonding. So now one X molecule as 18 electrons in it. One X molecule is having 18 electrons in it. How many NB electrons? How many Na electrons? Ama, nothing is there. Stability. If the bonding electrons are high, than the antibonding electrons, that is more stable. That's it. You can see here the bonding. This is a bonding molecular orbital. This is antibonding molecular orbital. This is bonding molecular orbital. Bonding molecular orbitals electrons are 4. Antibonding electrons are 2. So the number of bonding electrons are more than the antibonding. It is more stable. Now, if we take the helium 2, here the bonding electrons are 2, antibonding electrons are 2. Both the bonding electrons and the antibonding electrons, if it is both are equal, that is does not exist only. It will not exist only. Right? Now my question is, now the one X molecule is having the 18 electrons in it. Now how many bonding electrons or how many antibonding electrons? Now you say me. Say me. Say me, my dear friends. If you know the answer, say me. If not, give me the question mark. Yes. 10 bonding and the 10 anti-bonding, right? Now the 18 electrons means, now energy order we have to use above 14 electrons. Above 14 electron energy order we have to use, that we are having sigma 1s, next sigma star 1s, next sigma 2s, next sigma star 2s, right? Next we are having the pi 2pz, next sigma 2pz, next pi 2py equal to pi 2px. Now the pi 2py we are having the 1 electron, and sigma 2py x we are having the 1 electron, and here the 1 electron. Total how many electrons filled? Here 8, 9, 10, 11, 12, 13, 14, right? Then after that pi star 2py equal to pi star 2px, next sigma star 2pz, right? Up to 14 electrons filled, 15, 16, 17, 18. Now you count. Here the antibonding electrons are 2, antibonding electrons are 2. Here the antibonding electrons are 2, antibonding electrons are 2. So Na is 8. Remaining bonding electrons 2, 4, 6, 8 and 10. Total 10. Right? Bonding 10, antibonding 8. Good, Joshita. Good, Jasmine. No. Next one, the bond order. If you want to find the bond order of the any elements will be calculated by number of bonding electrons minus number of antibonding electrons. Clear? But no need of using this formula and all. Up to 20 electrons, bond order trick. Up to 14 electrons, up to 20 electrons, bond order trick. Right? Now, up to 20 electron bond order trick, we know, right? If the number of electrons, and this is a bond order. If the number of electrons are 1, bond order is 0.5. If the number of electrons are 2, bond order is 1. If the number of electrons are 3, bond order is 0.5. If the number of electrons are 4, bond order is 0. If the number of electrons are 5, bond order is 0.5. If the number of electrons are 6, bond order is 1. Okay. If the number of electrons are 7, bond order is 0.5. If the number of electrons are 8, bond order is 0. Right? Up to 8 electrons, you remember this bond order. Up to 8 electrons, you remember this bond order. Then after the 8 electrons, now from the 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. From the 9 electron onwards, what you do? Here the 0 bond order, right? From here you increase the 0.5 bond order up to 0.5 bond order up to 14 electrons. 0.5, this is 1, this is 1.5, this is 2, this is 2.5, this is 3, up to bond order 3 you remember. Then after that, from the 14 electrons you will decrease the 0.5, it will become 2.5, it will become 2, it will become 1.5, it will become 1, it will become how much? 0.5. Here it will become 0. This is a bond order trick you have to remember. This is a one bond order trick you have to remember, right? If you remember this bond order trick, now whatever may be the bond order they may ask, you can easily you can identify and easily you can predict. Right now we'll see, if suppose O2 minus 2 if they have given, O2 plus 2 if they have given, and O2 if they have given, what is the bond order if they ask? Just you can identify O2 contains 16 electrons and the minus 2 indicates that 2 electron added, total 18 electrons. Now here O2 contains 16 electron plus 2 indicates 2 electron removed, that is 14 electrons. O2 contains 16 electrons, right? Now 18 electrons of O2 minus 2 contain, this bond order is 2. Sorry, not bond order is 1. This bond order is 1. Now 14 electron bond order is 3 and 16 electron bond order is 2. 16 electron bond order is 2. In this manner we can identify any atoms bond order very fastly. So now I will give you the one question. Now based on this question, now you have to say me N2, N2 plus, N2 minus, N2 plus 2, N2 minus 2. First you say me the bond order of 1. First you say me the bond order of 1, next to 2, next to 3, next to 4, next to 5. Order you say me, bond order increasing order, higher to lower, bond order high to low. Now say me the bond order of high to low. Very fastly you have to say me high to low. Bond order high to low. Bond order high to low you have to say me. No, from the high to low you have to say me. First to find the electrons. First to find the electrons. Then after that, okay. First one is 3. N2 is having the bond order 3. Okay. Then after N2 bond order is 3. Next one N2 plus, bond order high to low. High to low. 1 is 3. Good. Okay. Good. Good. Good Vaishnavi. Good Jasmine. 1 is having the 3. Next. Next. Second is 2.5. Good. 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 Second is 2.5. Second is 2.5. Next. Now third is also 2.5. Good. Next fourth. Yashwant 1, 2 equal to 3 and 4 equal to 5. Good. 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 Good Yashwant. Good. Now here it is having the how many electrons? 12 electrons. And here it is having the 16 electrons. Then here it is having the 4, it is having the 2, and 5 it is having the 2. Then the bond order will be 1 greater than, 2 greater than, 3 greater than, 4 greater than 5. Then, sorry, 1 greater than, 2 equal to 3, and 3 greater than, 4 equal to 5. Now this is a bond order we got. Okay. This is a bond order we got. Now, whatever the bond order we got now, this bond order, now here bond order is same. Then if they ask, if they ask which is having, which is among the N2, N2 plus, N2 minus, N2 plus 2 and N2 minus 2. Okay, which now bond length order. Now you say me bond length order. Bond length order you have to say me. Now what I said, bond order is inversely proportional to the bond length, I said, right? But if suppose bond orders, if it is same, then how to decide the bond length? 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 Now say me. Then how to decide the bond length? Bond order, if it is same, then how to decide the bond length? Can anyone? If you know, you can say me. If not, give me the question mark. I will explain. If you know, you can say me. If not, I will explain. Now, here I explained very clearly, right? What I explained, you can see here the bond length, bond order is inversely proportional to the bond length. Here, the only the point you have to remember, if number of electrons are, if the number of electrons are high in ABMO, bond length, what if the number of electrons are high in the ABMO, bond length, what it will happen? Bond length will increase or decrease. The number of electrons are high, the bond order will be decreased. Bond order will be decreased, the bond length will be. The number of electrons are high in the ABMO, bond length will be high, because its bond order will be decreased and it will not be the stable, Clear? Here you can see N2, if you take sigma 1s, sigma star 1s, next sigma 2s, sigma star 2s, next pi 2py equal to pi 2px, next sigma 2pz, next pi star 2py equal to pi star 2px, next sigma star 2pz. Now you fill the electrons and you cross check and you have to say me now. Fill the electrons and you have to cross check. Say me now. Now, here what I said, if the number of electrons are high in the ABMO, bond length will be increased. Now you see and say. Now you cross check and say me. Now you cross check all the elements. This point you have to be very careful. This point you cross check and you say me. In which case the ABMO electrons are high, in which case the BMO electrons are less. N2, N2 plus, N2 minus, N2 plus 2 and N2 minus 2. Now the 14 electrons right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here in the N2, the BMO electrons are 10, 1. BMO electrons are 4. Here 8, 10. BMO electrons are 10. Right? Now antibonding electrons are, ABMO electrons are, now here now you can see BMO 10, ABMO, how many? ABMO 4. Now when it comes to the N2 plus, now you say me Amma, N2 plus how many BMO, how many BMO electrons and how many ABMO electrons? How many BMO electrons, how many ABMO electrons? Now you say me, in the N2 plus how many BMO electrons, how many ABMO electrons? Good H1, good. Now N2 plus you say me, how many ABMO and how many BMO? How many ABMO, how many BMO? How many ABMO, how many BMO? How many ABMO, how many BMO? In the N2 plus how many ABMO, how many BMO? 9 BMO, right. ABMO, here we are having the, right, 9 BMO. 9 BMO, next 4 ABMO. Now N2 minus, in the N2 minus, in the N2 minus, right, good, 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 everyone good. Now in the N2 minus, N2 minus, right, N2 minus, N2 minus we are having, right, N2 minus we are having the BMO, ABMO. ABMO we are having 5. Now BMO we are having 10. Now N2 plus, N2 plus, N2 plus 2. N2 plus 2. N2 plus 2 means 12 electrons, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Means in the N2 plus 2 BMO 1, 2, 3, 4, 5, 6, 7, 8. BMO 8. ABMO 4. Now here BMO 10. ABMO 6. ABMO 6. That is N2 minus 2. N2 minus 2. N2 minus 2 will having the BMO 10 and ABMO is a 6. Now you cross check. N2, BMO, ABMO. BMO is 10, ABMO is 4. N2 plus BMO is 9, ABMO is, how many? ABMO is 4. N2, N2 minus. Here the BMO is 10, ABMO is 5. right? Next one, here the N2 plus 2, N2 plus 2, BMO is equal to 8, ABMO is equal to 4, right? Next, N2 minus 2, BMO will be equal to how many? 10. ABMO will be equal to what? 6, right? ABMO will be equal to 6, right? Now, based on this one, now we have to identify the bond length. Here, what I said, as the number of anti-bonding electrons are high, as the number of anti-bonding electrons are high, what bond length will be high, right? So N2 minus 2 is having the higher bond length. Then after that N2 minus, then after N2 minus. Now you can see here the 4 bonding electrons, here the 4 bonding electrons, here the 4 bonding electrons. Then if the bonding electrons, if the bonding electrons are, if the anti-bonding electrons are same, then you cross check the bonding electrons. Then you cross check the bonding electrons. Then what you cross check, if the anti-bonding electrons are same, then you cross check with the, here the electrons which are having, the electrons which are having high bonding electrons or high bonding electrons, less bond length. If ABMO electrons are same, if ABMO electrons are same, then high BMO electrons, high BMO electrons will have less bond length, will have less bond length, means less BMO electrons, more bond length. Then N2 plus 2, then N2 plus, last is a N2, last is a N2. This is a bond length order you have to remember. This is a one very key point. Repeatedly they are asking, repeatedly they are asking in your all the what entrance exam, whatever it may be, you are preparing. I hope it is clear. Or still we do the some questions regarding this one. We'll do some questions based on this one. My dear friends, we'll do the questions based on this one. No, we'll do the hybridization and all. Now, I will give you some question. Now you have to say me the answer for this one. Right? Here, what is the bond order of CN? What is the bond order of NO? What is the bond order of CO? And what is the bond order of C2? And what is the bond order of B2? And what is the bond order of He2? And what is the bond order of Li2 plus? And what is the bond order of Li2? And what is the bond order of Li2 plus? Now, fastly you have to say me the bond orders of the 1, 2, 3, 4, 5, 6, 7, 8, and 9. Fastly you have to say me the bond orders of this one. Fastly you have to say me the bond orders of this one. Now say me the bond orders of this one. Fastly. Bond orders of the given species. Fastly, you have to tell me what are the bond orders of this given species. CN is 3. Good. Okay. CN is 3. My dear friend, once you cross check whether the CN is 3 or not. Whether the CN bond order is 3 or not, once you cross check, my dear friend. My dear friends, once you cross check whether the given bond orders are correct or not. CN how many electrons and what is the bond order? My dear friend, this is a carbon contains 6 electron, nitrogen contains 7 electron. Both if you add it is 13 electrons, right? 13 electron bond order is 2.5. 13 electron bond order is 2.5. Yes, yes. Good, good, good. First one is a 2.5. Next one. Yes, yes. Okay, good, good, good. Yes, first one is a 2.5. Second one. Second one. Second one bond order. What is the second one bond order? Second one bond order 2.5. Why? Oxygen 8, nitrogen 7. Overall, you will get the 15 electrons. 15 electron bond order is 2.5. No. How come 3.5? How come 3.5 NO bond order? 15 electron bond order is 2.5, right? Good, Vaishnavi, good. Fourth one, 3. No. CO bond order. CO third one bond order is 3 because carbon 6, oxygen 8. If you add 14 electrons, you will get 14 electron bond order is 3. Yes, good, good. Fourth one bond order is 2. Yes, good, good, good. Fourth one bond order is 2. Fourth one bond order is 2. Why? Carbon 6 electrons and another carbon 6 electrons and 2 electron. 2 electron bond order is 2. CO is 3. Okay, 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 fine. Fine, Amma Joshita. Okay, fine. Next, Be2. Be2 bond order. 1 is 2.5, 2 is 2.5, 3 is 3, 4 is 2.5, 4 is 2, 5 is 5 is 1, 6 is 0, 7 0 now. My dear friend, 7 is not 0. Here this is bond order is 1. Here the helium it is a 0 because 4 electron bond order is 0. My dear friend, Yashwant, 7 is not 0. Seventh one you have given the answer is 0, but seventh one answer is not 0. Seventh one answer is 0.5. Seventh one answer is 0.5 because it is having the 3 electron. 3 electron bond order is 0.5. You have given it as a 3, sorry 0, but it is wrong. Li2 6 electrons, bond order is 1, and the last one is 0.5. 0.5. Good. Okay. Now this is a trick you have to be remember carefully and you have to give the answers. You have to give the answer, right? Now, next question. You have to be very careful with the next question. What is the next question we are going to see? Be2 plus Be2 plus Be2 plus is diamagnetic, dia or para, if it is dia, last electron present in which orbital, which molecular orbital. If it is para, unpaired electron is present in which molecular orbital, now same Be plus 2 is whether is dia or para. If it is a dia, last electron is present in which molecular orbital. If it is a para, that unpaired electron is present in which molecular orbital. Now same. I was asking that unpaired electron is present in which molecular orbital, whether it is a sigma 1s, or whether it is a sigma 2s, or pi star 2py, or whether it is a pi star 2px, whether it is a pi 2py, or whether the pi 2p, whether the sigma, that you have to say me. Okay. Joshita is saying that it is a paramagnetic and that unpaired electron is present in pi 2py. Now we'll see, this is having the 9 electrons. 9 electron energy order will be sigma 1s, sigma 2s, sigma 1, sigma star 1s, sigma 2s, sigma star 2s, and it is a pi 2py, and it is a pi 2px. Now the how many electrons? 9 electrons at 1, 2, 3, 4, 5, 6, 7, 8, 9, clear 9, and that electron is present in the pi 2py, and the unpaired electron is present, right? So that is a paramagnetic, and that unpaired electron is present in the pi 2py. Good. Paramagnetic, and that unpaired electron is present in pi 2py. Now next one. In F2 molecule, last electron present in which MO, which molecular orbital. In the F2 molecule, last electron is present in which molecular orbital. Now in the F2 molecule, last electron is present in which molecular orbital? Now say me, my dear friends, fastly. In F2 molecule, last electron is present in which molecular orbital? If you know the answer, say me. If not, yes, good. The last electron will be present in the pi star 2px or pi star 2py. Now the F2 is nothing but 18 electrons. Now we know sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, next sigma 2pz, pi 2py equal to pi 2px, next sigma, sorry, pi star 2py, this is a pi star 2py, and this is a pi star 2px, last is a sigma star 2pz. Yes, yes. Now we have to fill the 18 electrons, right? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Last electron is present in either the 2px or the 2py. Anything you can take, anything you can take, either 2px or the 2py, anything, both are correct only. Hi Richard, hi. Now my dear friends, I will give you the some questions I will give you. Now these questions, whether it is a diamagnetic or paramagnetic, if it is a diamagnetic, the just you comment your answers in the comment section. Okay. Now just whether it is a diamagnetic or paramagnetic. First one, it is a C2. Now whether it is a dia or para, you just comment in the comment section. Second one, Ce2 plus 2. Now third one, He2 plus. Now the fourth one, H2. Fifth one, Li2. Sixth one, O2 minus 2. Seventh one, O2. Eighth one, CO. Ninth one, Cn. Tenth one, N2 minus 2. N2 minus 2. Okay, my dear friends, this 10 compounds, whether it is a para or dia, whether it is a para or the dia. Now I will see how many of you will give the correct answer, and very fastly in the comment section I will see. Okay, how many of you are the following? No, you just give in the comment section. I will pin that comment so that the students who are want to learn, or the one who are seeing the video, they can see the cross check your answers in your comment section. Okay, once you comment your answers in the comment section, I will pin the first who has commented the answer, that those answers will be pinned. Okay, right. Now my dear friends, give your answer in the comment section, not here. Now by here I was ending the live. Now see you tomorrow with the question session. Complete question session tomorrow we are going to see. Okay, my dear friend, the complete question session. Be thorough with the concept. If you are having any misconceptions in your concepts or anything, just you clarify it. Go thorough, go through the notes very fastly. I mean, concept, try to strengthen your concept. Then tomorrow we are going to see the n number of questions. Try to solve that n number of questions. It will be helpful for your what in your preparation for the JEE or as well as NEET. Okay, my dear friends, if you are having any confusion or if you are having any concern, you can ask. Remaining, they can leave. My dear friends, give the answer in the comment section, not here, so that it will be helpful for the students who are seeing later. They can have that answers and they can cross check over there. Clear? Okay. Bye bye. See you tomorrow. See you tomorrow, my dear friends. Should I end the live? Should I end the live?